These kinds of exercises get you used to the definitions for the truth functional operators, and they also get you used to the idea that truth functions are functions. Given some input or other, you put those input values into the function and you get an output value. So for example, if we take a look at this first one, the left disjunct is true and the right disjunct is false. A function is being identified. It's the disjunction function, and your inputs have been identified. The left disjunct is true, and the right disjunct is false. And given the definition of disjunction, which is that a disjunction is true whenever either of the disjuncts is true, then this compound sentence is true. It can help sometimes to fill in an ordinary language example. So keep the logical connective the same, and you'd find a true sentence. Maybe something like, the Mariners play at T-Mobile Park. Or, and then you'd find a false sentence, like maybe the Mariners play at Oracle Park. This sentence is true. This sentence is false. And the entire compound is true. So let's take a look at number 11. Here, we're being told that the antecedent is false and the consequent is true. This lets us know that we're dealing with a conditional sentence. And the if part, or the antecedent, is false, and the then part, or the consequent, is true. On the definition of conditional, this compound sentence is true. Conditionals are only false when the antecedent is true and the consequent false. In all other conditions, they are true. This may seem a little counterintuitive, but here's an example that might help you remember this definition. I take this sentence. If Felicity is a dog, then she is a mammal. This intuitively is a true compound sentence, right? But suppose that Felicity is actually a cat. The truth value of this sentence doesn't and really shouldn't change either, right? Even though what we have is a case of a false antecedent. Felicity is not a dog, she's a cat. Then she is a mammal, which she is, though, still a mammal. Right? The thing to remember with the logical conditional is that it is a material conditional. If it doesn't really make sense to you, just memorize the definition. But it does, in a way, if you think about examples like this, the logical definition does actually make sense, does track what we want a conditional to do. All right, now let's take a look at number 12. Again, given that we're talking about antecedents and consequence, we know that we're talking about the conditional, and precisely we're talking about a false antecedent and a false consequent. The compound sentence is true, again, just following the definition of conditional. With 13 and 14, we're dealing with negations. Right? The embedded sentence in the negation is true. So we're looking at something like this. It is not the case that something, and that something is true. By definition, the compound sentence is then false. Negation simply just switches the truth value of the embedded sentence. Again, we're dealing with a negation. You can abbreviate "it is not the case that" with this. So not something, and that something is false in this case, means that the compound sentence is true.